Hi, I'm Michael Woods, Chief Scientist at the Asian Turfgrass Center. This is another ATC Doublecut. I'm going to give an update about some of the things that I've been writing about on the ATC blog. I'm coming to the end of what's been a rather long trip. I've been in a couple countries, and in the United States, I just thought about it. I've spent nights in 7 different states now. I've passed through a few other states where I didn't spend the night, but I'm now at a place which would be the 7th state where I'm spending a night, and I haven't been able to record any of these double cut episodes for a few weeks. So there's been quite a few things that I have had time to write about on the blog, and I want to share some of those highlights with you to explain some of these things that I think are especially interesting and especially worth your time. If you want to check them out, going to my website, asianturfgrass.com, or checking out some of the videos that I've posted recently on the YouTube channel. The first thing that I want to talk about is the recorded presentations that I made from the ATPI conference, the Association of Turfgrass Professionals Ireland, where I spoke in early March. I gave 2 presentations there. One was on systematic improvement of course conditions. And this is a topic that I think is really interesting because it's basically, I don't really use the word very much, data-driven turfgrass management. I would rather just focus on improving turfgrass conditions. But to improve the conditions, sometimes you need to know where you're at and have an idea of what direction you want to go. So maybe it does involve some data in terms of measuring the performance and measuring how much fertilizer's been applied, measuring how the soil test changes, and so on. I have a blog post called Soil, Grass, and Playability, in which I talked about that, and I recorded the presentation that I gave in Ireland on systematic improvement of course conditions. And then there was the one that I think is even more interesting, which is Bah Humbug. I call it Bah Humbug because I would have said as recently as 8 years ago, if someone would have told me that it would be possible, perhaps even desirable, perhaps a good idea to apply less sand top dressing and remove less organic matter by coring than I had previously recommended. Something that was very interesting for me as I was preparing that Bah Humbug presentation was to look up a presentation that I gave about organic matter 8 years ago in 2014. And I included one of those slides in the presentation. In that Bah Humbug presentation that I gave in Ireland, I included a slide from a presentation that I'd given in India in 2014. And in that 2014 presentation, 8 years ago, I was recommending to apply a substantial amount of sand every year as top dressing. And I was recommending that every golf course, no matter where you are, to remove a substantial amount of the surface area by coring, removing that material, and then replacing it with clean sand. Specifically, I was recommending about 12 to 15 millimeters of sand. At minimum, I wanted a sand top dressing amount on an annual basis of 12 millimeters, which comes to be 40 cubic feet of sand per 1,000 square feet. That's what I was recommending. And it's very interesting for me to now give the Bah Humbug presentation in which I say I don't recommend that anymore. I'm recommending a totally different approach. And the approach that I recommend now, which I hope you will watch the Bah Humbug presentation to find the details, what I'm recommending now is to measure the total organic matter in the soil, what I call the OM246 test. Measure that, keep track of how much sand has been applied, and keep track of how much surface area is removed, and then test again. As you do that, you'll be able to calculate your site-specific organic matter accumulation rate. And from that, you can then adjust the sand top dressing amount that you should apply in the future in order to adjust the organic matter on a site-specific basis to however you want it to be. That's what I recommend now. And that's the highlights of that particular post, the post that I called soil, what did I call it? Soil, grass, and playability. And I was talking about systematic improvement of course conditions and coring and sand top dressing in Ireland. That was a post that I put up last month. And the next one I did was on March 20th. And this one I called a turfgrass tissue testing manifesto. This was after I'd done an ATC office hours episode with Doug Soldat. Doug is a professor at the University of Wisconsin, and we have similar views on fertilizer requirements, soil testing, tissue testing, and the utility of those. But there are a couple subtle differences that we have, especially about tissue testings. And Doug was kind enough to join me on the ATC office hours, and we talked about it. And when I record these office hour episodes, it's easy for people to understand them if English is their native language. But there are people who follow this topic all around the world, and some people would prefer to read it or have it summarized, because if English is not your first language, it would be difficult to understand completely what Doug and I were talking about. So at the request of one of my followers, I tried to summarize our talk. Well, it turned out that it became a turfgrass tissue testing manifesto, which is what I called that post. And the reason it's a manifesto is because I've been thinking about this for a long time, and I've been writing about it for a long time. And after I talked with Doug about this, tissue testing and the utility of it, or the lack of utility of it, was fresh on my mind. I summarized our conversation with a few bullet points, and I'll quote here from the post. One of them was, neither of us being myself and Doug, neither of us think it's a particularly effective practice to chase target leaf tissue concentrations. Doug recommends regular but infrequent testing of good performing turf at your site for the purpose of developing a reference data set for your site of what nutrient levels are normal. I don't recommend this testing because it is not clear to me how these data can be used by a turf manager once the reference data set is developed. Doug points out some specific cases of lower potassium in annual leaf tissue being associated with higher anthracnose disease incidence, and higher potassium in creeping bentgrass leaf tissue being associated with higher snow mold disease incidence. I am aware of these experiments and that potassium has an effect on disease incidence in these cases. It seems clear that potassium supply to the grass affects the disease intensity. I'm not so confident that the specific leaf potassium levels identified in those experiments would transfer to different locations, because those different locations would have different soil, different weather, and different management. I agree with Doug that it might be useful for turfgrass managers to develop their own site-specific normal data set of leaf tissue nutrient levels, but I don't recommend it because, number one, I'm not optimistic about the data being useful even after they're collected. And number two, it costs money to generate the data, and I expect high quality turf can be produced with an efficient nutrient supply by completely ignoring site-specific tissue testing reference ranges. I'm happy to allocate those funds to something that will have an impact on improving turfgrass conditions, and I just don't see that it happens. I don't see how it can happen effectively with a site-specific reference data set of tissue nutrient levels. So as you can see, this turns into a bit of a manifesto because I went on to elaborate and I talked about cause and effect. Because when you make decisions about what fertilizer based on what the tissue test result is, you're assuming that the tissue test result has some causal effect on what the turfgrass performance will be. And I think it's very difficult to establish that. And I'm not confident that that's actually a real thing. And in most cases, it gets a little bit complicated. So I've seen so many cases of excellent turfgrass where we don't know the tissue nutrient levels, and you wonder, well, if we did know the tissue nutrient levels, what would we do? How would we change the management if we did know the leaf nutrient levels? That's not so clear to me. Perhaps somebody can elaborate, and I'll be happy to change my mind when I understand how this would actually work well. At this point, I just don't see how it does work well. And I shared a chart that I made in 2005 when I was still a graduate student at Penn State. And this shows a wide range of tissue nutrient levels in the dry matter. And it also shows that plotted against leaf potassium content expressed on a tissue water basis. And on a tissue water basis, that is potassium per liter of water in the soil. I think that was millimolar. So it's millimoles of potassium per liter of, did I say water in the soil? I mean water in the leaf. So it looks at how much water is in the leaf, how much potassium is in that water. And for all of these samples, it was completely in a normal range because the biochemical threshold for potassium in the tissue water is expected to be something like 80 millimolar. So anything above 80 millimolar, you'll have enough potassium in the leaf to perform all the functions that potassium needs to apply. And anything beyond that is just extra. So even across a wide range of potassium in the leaf on a dry matter basis, which is the way that it's customarily reported, there was always enough potassium in the leaf. And I think because of this type of relationship that is certainly true for potassium, perhaps for some other elements as well, it just gets extremely complicated to diagnose a problem by looking at what is the nutrient level in the leaf on a dry matter basis. It's something that I don't see how we can use in day-to-day turfgrass management. So even if we do have that reference set that is site specific, I'm not confident that it turns out to be something that we can actually use. And I also shared some recent data from 27 golf course putting greens in Thailand, in which there were tissue tests and there was also visual quality ratings at the same date that the tissue test was collected. The turfgrass quality was rated. And I did this for 3 different grass species, and these look just like scat plots. We have this for Bermuda grass, for seashore paspalum, and for Manila grass, zoysia putting greens. Leaf nitrogen content ranged from less than 2% to 6%. And there's no clear relationship between a peak level, an optimum level, a deficient level of leaf nitrogen for any of those species, indicating that turfgrass quality is higher or lower across any particular the turf quality does not appear to be affected by the leaf nitrogen content. And I think that's what we will tend to see if we collect these samples. it's really difficult to establish cause and effect. And if there's no cause and effect relationship within the range of leaf nitrogen content and within the ranges of turf quality that we typically have on golf courses or on sports fields or on any type of professionally managed turf, then I find it very difficult to understand how regular testing of leaf tissue content could be used with any effect to adjust fertilizer to be more efficient. I also showed this same chart for potassium, and it was the same thing. For all those three species, there is just a scatter plot of results where the turf quality, which ranged from 4 being that the turf is fair, it's easy to see how it could be made better, up to a maximum of 8 was rated very good. It's almost perfect with a few minor blemishes. It doesn't matter if the turf is it at the level where it's rated where it's easy to see that it could be made better, or if the turf is at the level where it's almost perfect with a few minor blemishes. It doesn't matter. The leaf potassium content, the leaf nitrogen content, and the leaf phosphorus content are the same at those levels. There's no trend of a certain level of leaf potassium or leaf phosphorus or leaf nitrogen being correlated with the turf quality. That to me is a huge problem that just says, hey, before we start saying let's start looking at tissue testing and trying to interpret it and thinking that these numbers mean anything, and that these numbers for leaf tissue nutrient content are something that we would ever take action on. I think we have to start by establishing that there is a relationship between turf quality and particular levels of leaf nutrient content. And in my data, I haven't found that, and I would need to be able to see that type of relationship of some type of close correlation between leaf nutrient content and turf performance before I would be comfortable using tissue testing as a way to make fertilizer recommendations. And then let's see, this post goes on to say the second point, I've noted the problem with cause and effect. But Micah, you may say, certainly there are elemental levels in the leaves that must be indicative of a deficiency, a toxicity, or a turf quality problem. You would say that because that's what we think. It must be like that. And I agree with that. But a problem remains by the time an abnormality of that degree, and I'm talking here about a deficiency, a toxicity, or a turf quality problem. By the time an abnormality of that degree is detected in the leaves, the grass already has a problem. And what we end up doing is a post-mortem type of analysis. I don't really want to make a post-mortem type of analysis on professionally managed turf. I want to prevent those kind of problems. And I think we can do that by careful consideration of which fertilizers are applied, which nutrients are applied as fertilizer. And we can also do this by soil testing, because soil tests look at what the grass has not used. Soil tests look at what the grass has not used yet. And it's much easier to interpret soil tests and from soil test interpretation to predict what nutrients would be applied or would need to be applied as fertilizer. That was a very interesting conversation that I had with Doug Soldat. That's available on the ATC YouTube channel. You may like to watch that to hear the intricacies of what we agree about and what we slightly, well, I don't know that we even disagree, but I would say that we make slightly different recommendations about how people should actually use tissue tests. I think the big difference in the recommendation is I say, don't bother with it I'm not optimistic that it will ever be worth your effort. And Doug says, why not? It doesn't cost too much money. Go ahead and collect some data so you'll have some site specific reference ranges. I'm not optimistic that those site specific reference ranges will be useful. So I say, don't spend the time and money. Do it. And I'm going to talk about one more post. The next post was answering a question that I received by email. This post is called MLSN and Correcting Soil Deficiencies. I put deficiencies in quotes because the question was related to the question that I received was related to deficiencies. I'll read a few quote from that question. Let's see. The email began. I was listening to your podcast regarding the MLSN nutrition method as I've begun using it at my golf course. It's still new to me and a little confusing. Let's see. And then the correspondent goes on to say, the one thing I'm a little confused about is how you correct deficiencies. I often have deficiencies in my soil tests with potassium, calcium, and magnesium. An example of this would be a calcium recommendation of 500 kilograms per hectare of gypsum, about 450 pounds per acre, to correct the deficiency, or a recommendation of 105 kilograms per hectare of actual calcium. That's about 94 pounds per acre. Therefore, how do I correct my calcium deficiency to get it back to where it needs to be? Because the MLSN recommendation is much lower than that. And I responded with this and started putting the word deficiency in quotation marks. I said, regarding how you correct deficiencies, this is something related to the soil test interpretation. If you use MLSN for soil test interpretation, the result of this calculation will be a recommendation for an amount of nutrient that is certain to be enough to meet all the grass and soil requirements. Regarding the example of calcium that you shared, the deficiency in quotes is apparently calculated by a different method, and it seems you are assuming that the deficiency, again in quotes, is real. And that's really the key thing. What I'm saying is those are not deficiencies. If you get your soil test done, and not every fertilizer company is like this, but a lot of times when you get your soil test done through a fertilizer company, they will interpret it not using MLSN, but using some other method where they have these very high target ranges in the soil. And then they will say, if your soil is not at that target range, then they would say that's your deficiency. And then they can recommend a lot of fertilizer to try to get your soil up to that target level. What I've been saying for years and years is that those target levels are unreachable simply because the soil cannot physically hold that amount of nutrients. And that's because when you add fertilizer, you don't increase the soil's ability to hold it, do you? So there's a bit of a numbers game because they're saying on that recommendation that your soil should be at a high target level that it's not at. And the reason that it's not at that level is very likely because the soil simply can't hold that many nutrients. And if the main thing we want to look at is what is the turfgrass performance? If the turfgrass performance is fine, then clearly it's not deficient in something. And trying to increase the soil nutrient levels just for the purpose of hitting some target range in the soil, that is quite disconnected from turfgrass performance. That doesn't make any sense to me. I went on to elaborate on that. You can read more about that in the blog post. Let's see. I write about this in the final paragraph, so I'll read some of this too. I didn't elaborate any further in my reply, but there seems to be something wrong with the soil test interpretation if it is often finding deficiencies in calcium, magnesium, and potassium. And when the annual recommendation of an element is 7 times more than the plant can use, that's also an indication that there may be something quite wrong with the interpretation. I recommended a case study about implementing MLSN from Carl Scamenti at Cornell University. And that's a really interesting case study. There's a link to that in the blog post. I also did not mention in my reply about considering where the recommendation is coming from. It can be helpful to consider whether the fertilizer recommendation is coming from a company that is also selling the fertilizers being recommended, because there's obviously a bit of bias there or a bit of conflict of interest if you're getting your soil test done and the fertilizer recommendations coming from the company that is selling those very products. That is a quick overview of 3 recent blog posts on the ATC website. And this is something that I have been writing about as I've been traveling around. You may have read some of those. If you haven't, please go to asianturfgrass.com if you're interested in these topics and check out a few of the links there or a few of those posts that I was talking about if any of this interests you. I will share some more of the things that I've been writing about. That isn't all the recent blog posts, so I'm going to record another episode soon and share my comments and thoughts about some of those also. For ATC in Salem, I'm Michael Woods.